Hey guys, we're continuing with our notes from Friday. We're starting with number 12. We're going to find the mean, median, mode, and range of each data set. So let's look closely. It says the distance in yards of each successful field goal attempt made by a kicker in his last practice. So in order for me to find the mean, median, mode, and range, the first thing I really need to do is rewrite my data in numerical order. So starting with my smallest value and ending with my largest value. So when I look at this data set, 36 looks small. I see two 36s. Those are the only numbers in the 30s. So we start with 36, and then we have another 36. And because I will mess things up if I don't mark them off, I'm going to mark them off as I go. Now my next smallest number is 40. Okay, then I see a 42. I see a 43. The next smallest number I see is 45. And then the last numbers are both 52. And then I've got 159. Okay. So I've got my data in order here. So now I'm ready to find my mean, median, mode, and range. In order to find my mean, that's the average of all my numbers. I'm going to add all of these numbers together. So in my calculator, 36 plus 36 plus 40 plus 42 plus 43 plus 45 plus 52 plus 52 plus 59. And when I put that into my calculator, I end up with 405. And I'm going to divide that by the number of terms I had. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So I'm dividing 405 by 9. So 405 divided by 9 is 45. So my mean is 45. Think of your mean as your average. Now the median is the number in the middle of a data set. So I need to find the exact middle of this data set. The way I'm going to do that is I'm going to cross off and work my way towards the center. So I'm going to cross off my smallest value and then my biggest value. And then I'm going to cross off my next smallest and my next biggest. And then I cross off my next smallest and next biggest. And I'm just working my way towards the center. And I see that I'm left with this number right here. That is my median. So 43 is my middle value. Okay, the mode is the number that occurs most often. And that's how I remember. MO stands for most often. It's the most repeated number in the data set. So when I look at this data set, I can see very clearly that I have two 36s, I've got two 52s, and all the other numbers occur just one time. So I'm going to consider both 36 and 52 to be my modes. So 36 and 52. Okay, and then finally my range. My range is found by taking my biggest number and subtracting the smallest number. So our biggest number is 59. Our smallest number is 36. So 59 minus 36 should give you 23. So 23 is my range. Okay, let's look at number 13. The number of minutes that Ed, a customer support specialist, has spent on his last 12 phone calls. So we've got 12 numbers here. We have to put them in numerical order. So looking at the data, I see the first number I see that's small is 5 and followed by 7. So we've got 5, then 7. Then the next numbers that I see a 12. So after 12, 16 followed by 18. Okay, after 18, I see a couple of 20s, two 20s, right? Okay, after 20, I see two 24s. Then I see a 28, a 35, and a 43. Okay, so I've got all of my data in order. 5, 7, 12, 16, 18, 20, 20, 24, 24, 28, 35, and 43. So let's find the mean. In order to find the mean, I'm adding all of those numbers together. So 5 plus 7 plus 12 plus 16 plus 18 plus 20 plus 20 plus 24 plus 24 plus 28 plus 35 plus 43. When I put that in my calculator, I get 252. So for the mean, we have 252, and I'm going to divide that by the number of terms. And it told us that it was his last 12 calls, right? So because it's his last 12 calls, I know that there are 12 numbers. So 252 divided by 12 gives us our mean, and that is 21. So the average is 21 minutes per call. Now let's find the median. So to find the median, I'm going to cross off numbers from the small end and the big end and work my way towards the center. So I've got 5 and 43 are gone, 7 and 35 are gone, 12 and 28, 16 and 24, 18 and 24. So if you look at this, I've crossed off 1, 2, 3, 4, 5 numbers from the small side and 5 numbers from the big side. And I'm left with 2 numbers in the middle. That means that my median, my middle number, is in between these 2 numbers. So when this happens, the way I'm going to find my median is I'm going to take the average of those 2 numbers. So I would take 20 plus 20 and divide that by 2. Now we know that 20 plus 20 is 40. And we know that 40 divided by 2 is 20. So when the number is the same, when you have a situation like this and the number is the same, that tells you that your median is going to be the same number. But if you had 2 different numbers, like for example, if we had had 20 and 22, my median would have been the number in the middle of those 2 numbers. Okay, so keep that in mind. Now the mode, remember the mode is the term that occurs most often. So when I look at this data set, I see that I've got 2 20s and 2 24s. All the other numbers repeat or just occur one time. So because of that, my modes are 20 and 24. And finally, my range. I find my range by taking my biggest number and subtracting my smallest number from that. So looking at my data, my biggest number is 43, and my smallest number is 5. So 43 minus 5 gives you 38. So that right there is your range. Okay, moving on to the next page. We're skipping 14 and 15. We're not doing mean absolute deviation, but we are going to look at topic 5, box and whisker plots. So find the 5-number summary and construct the box and whisker plot for each data set. So 16, the mileage in thousands of miles of 10 cars in a used car lot. So we've got these numbers here. My first step is to put them in numerical order. So let's start with our smallest number. I see a 36, and that is our smallest number. And the next smallest number I see is 54. After that, see a 60. And then a 68. After that, there's a 72. And a 78. And then I've got an 82. A 90, a 95, and a 110. Okay, so now that my data is in order, we're going to start looking for our 5-number summary. And our 5-number summary are these numbers here. Now, the minimum is exactly what you think it might be. It is the smallest number in the data set. So looking at our numbers here, I know that 36 is my minimum. Okay, so let's go ahead and write that over here. Now, going down to the bottom, the maximum. The maximum is exactly what it sounds like. It's our biggest number in the data set. So in this case, this number right here is our maximum, so 110. Now, the median is the other number that you already know how to find. It's the middle number in our data set. So I'm going to cross off, starting with my smallest and working my way towards the center. So cross off 36 and 110, 54 and 95, 60 and 90, 68 and 82, and I'm left with 2 numbers. So I know that my median is in between those 2 numbers right there. So I'm going to find the average of those 2. So we had 72 plus 78, right? And I'm going to divide that by 2. So in my calculator, 72 plus 78 equals 150. 150 divided by 2 is going to be 75. So I know that my median then is 75. Okay, now to find the lower quartile, what I want you to know about the lower quartile is it is the median of the lower half of the data. So I'm going to write that. So it's the median of the lower half of the data. Okay, so let's look at just the lower half of our data. The lower half of our data includes all the numbers up to the median of the whole data set. So it's going to include 36, 54, 60, 68, and 72. So that's our lower half. And I'm going to find the median of those numbers there. So I know it's not going to be 36 or 72. It's not going to be 54 or 68. It's going to be this number right here. That is our lower quartile number. So 60. Okay. Now, just like the lower quartile is the median of the lower half of the data set, the upper quartile is the median of the upper half of the data. So I'm going to look at all the numbers above the median. So this time I'm looking at 78 all the way to 110. And I'm going to find the median of that half of the data. So I know it's not going to be 78 or 110. It's not 82 or 95. It's going to be this number right here. That is my upper quartile, 90. Okay, so now that I've got my 5-number summary, I can make my box and whisker plot. So I first need to kind of label my number line here. So I think I'm going to start with 35 and count by 5s. So 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, and 110. Okay, so the first thing I'm going to do is place my minimum and maximum points. So my minimum was 36, so it's just going to be right above 35, so maybe about right there. So I'm going to place a circle right there. And my maximum we know is 110. So, oops, right there. Okay, now my median My median is 75. So at 75, I'm going to place a line. Okay. Now, my lower quartile was 60. At 60, I'm also going to place a line. And my upper quartile was 90. So at 90, I'm also going to place a line. And I'm going to box in these 3 lines. So I create a box right here. Now, I'm going to draw my whiskers to my minimum and to my maximum. So they look like this right here. So that is what my box and whisker plot looks like. Now, what I want you to know about this is that each section of the box and whisker plot represents 25% of the data. So 25% of my data would be from 36 to 60. Another 25% would be inside this half of the box, another 25% right here, and then the last 25% of the data is on that side of the box, all the way up to the maximum. Okay, moving on to number 17. The ages of each player on a basketball team: 29, 33, 22, 27, 28, 28, 25, 32, 32, 29, 33, 25, 23, 24, 24. Okay, so our first step is to order the data in numerical order. So the smallest number that I saw was 22. After 22, I have a 23 right here. Is that the only 23 I have? I think so. I've got a 24 here. Another 24. Those are the only 24s I've got? Yes. Here's a 25. Here's another 25. Okay. I don't see any 26s, but here's a 27. And then 2 28s. And after that, I've got 2 29s. Okay. So I've got 2 32s. And then 2 33s. And that should be all of that data in numerical order. Okay, so looking at this, it's easy for us to spot our minimum. Our minimum's the smallest number is 22. And our maximum is the biggest number, it's 33. So let's now find our median, the middle of this data set. So I'm going to cross off one number from each side and work my way towards the center. And I find that this number right here is my median, 28. Okay, now let's find our lower quartile. Remember, that's the median of the lower half of the data. So everything up unto the median. So this right here is the lower half of the data. It does not include the median. So I'm going to find the middle of this set. So to find the middle of this set, I'm going to cross off from the small end and the big end and work my way towards the center. And I'm left with this number right here. That right there is my lower quartile. Okay, now let's find our upper quartile. So same thing, just with the upper half of the data set. So everything above the median and up to the maximum. So I'm just going to cross off and work my way towards the center. And I find that that right there is my upper quartile. So 32. Okay, so now with this 5-number summary, I can make my box and whisker plot. So I'm going to start, I think, with my number line. And I'm going to start by labeling it at 20 maybe and counting by 1. So that's 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35 would be that last number. Okay, so I just counted by ones, but I labeled every other one. Now let's place our minimum on here. So our minimum we know is at 22. I'll put a circle there, dot there. And our maximum is 33. So I'll put a dot there as well. Oops. Okay. Now let's put a line at our median, and our median was 28. Okay, let's put another line at our lower quartile, 24, and then another line at the upper quartile, 32. And I'm just going to connect all these lines with a box. So it looks like that. This one got shaded in for some reason. And then I'm going to connect my maximum to my box and my minimum to my box to create my whiskers. Okay, now let's talk about analyzing box and whisker plots. So number 18, Waterstone Crossing and Kingston Estates are 2 neighborhoods in the same city. Last year, 8 homes sold in Waterstone Crossing and 12 homes sold in Kingston Estates. Each home sold at a different price. The selling prices in thousands of dollars for each home are shown below. Okay, so we've got Waterstone Crossing on the top and Kingston Estates on the bottom. So which neighborhood had a greater interquartile range in selling prices? So here's what you need to know about an interquartile range. The interquartile range is the box. So the interquartile range for Waterstone Crossing is 240 minus 210. So Waterstone Crossing, 240 minus 210, which is 30. And remember, it's talking about thousands of dollars, so about $30,000. Now let's look at the interquartile range for Kingston Estates. So again, the interquartile range is the box. So to find the range of that, I look at the biggest side of my box, 240, and I subtract the smallest side from it, 190. So Kingston Estates, 240 minus 190 gives us 50. So which neighborhood had a bigger interquartile range? That would be Kingston Estates. Okay, B, what is the difference in the median selling price between the neighborhoods? Okay, remember that word difference in math means that we're going to subtract. Okay, so, and we're looking at the median selling price for both neighborhoods. So for Waterstone Crossing, the median is 230. For Kingston Estates, the median is 210. So 230 minus 210 gives us 20. What is the percent of the homes in Waterstone Crossing that sold for at least $240,000? So this time we're just looking at Waterstone Crossing. And we know we're looking for how many homes sold for at least $240,000. That means $240,000 and above. Okay, so Waterstone Crossing is the graph on top. So we're looking at $240,000 and up, right? So all that includes is this section of the data. And remember when I talked about how each section represents 25%, so this right here is 25%, 25% here as well, 25% here, and that means that this section is also 25%. So 240,000 and up is 25% of the homes. Okay, last one. How many homes in the two neighborhoods combined sold for more than $210,000? Okay, so how many homes in the two neighborhoods combined? So let's start with Waterstone Crossing. That's the graph on the top. And I'm looking at homes that sold for more than $210,000. So I'm looking from here and up, right? Well, when I look at Waterstone Crossing, that's 25% here, 25% here, and another 25% here. So 75%, right? So 75%. But how many homes sold in Waterstone Crossing? Well, it says 8 homes sold in Waterstone Crossing. So I'm going to take 75% as a decimal, so 0.75, and multiply that times the number of homes, 8. So 0.75 times 8 gives me 6. So 6 homes. Okay, now let's talk about Kingston Estates. So let's first find our percentages of homes that sold for more than $210,000. Well, $210,000 is again right here, so that's where our median is. So 25% are here, and another 25% are here. So that's just 50%. So how do I represent that as a decimal? 0.5, and I'm going to multiply that by the number of homes that sold in that neighborhood. And it tells us that 12 homes sold in Kingston Estates. So 0.5 times 12, I know is going to be 6. Okay, so how many homes in the two neighborhoods combined sold for more than $210,000? Well, I'm just going to take 6 plus 6, and 6 plus 6 equals 12 homes. Okay, so that is the end of our notes for today. Homework 18 is due on Monday.